All right. So as Ethan has mentioned, my name is Gavin Daynard. I am the emerging contaminant scientist at Wisconsin Sea Grant here. My career with contaminants per se started all the way back when I was very young. I kind of got super interested in this when I read Silent Spring by Rachel Carson. And you kind of learn about all these contaminants that are out in the environment and how they potentially having specific impacts on different wildlife out there, which really kind of led me to, it followed my path throughout all of my kind of college and now continued career. I went to the University of Miami down in Florida, where I studied marine science for my undergrad. There is where I got my first kind of insight to research, where we looked at some impacts from the BP oil spill back in 2008. And from there, I decided to continue on and pursue a PhD, where I went to the University of Wisconsin-Madison here. And my PhD work really focused pretty heavily on pesticides and specifically their impacts on native Wisconsin fish. So if you accidentally hear me say pesticides today instead of PFAS, that's just residual work from my PhD. And then after my PhD, I went and got a postdoc position with the Wisconsin Department of Health Services, where we helped create recommended groundwater standards for PFAS in particular, and we'll talk a little bit about that today. And so after that, I was fortunate enough to get a position as the emerging contaminant scientist here at Wisconsin Sea Grant. And Sea Grant is a really cool program that's been around now for a little bit over 50 years. And the role of this program that I play is really to conduct and communicate science, particularly revolving around emerging contaminants in the Great Lake ecosystem. And I like to focus a little bit on both environmental impacts, ecological impacts, and then how they are interconnected together. And so for today's talk, we're just going to learn a little bit about PFAS, which are per and polyfluoroalkyl substances, and really just start to understand a little bit of this new emerging contaminant. Now, we will really just scratch the surface of everything. So if you're continually interested, feel free to reach out at the very end. So my first kind of question to everybody, and feel free to throw it into the chat, but has anybody in the last month or so seen any news articles, either read anything about PFAS? Have you been seeing these kind of PFAS show up in our news at all? I'll see if we can use that chat. Find it on here. Okay, so one no, one yes, a couple yeses. Yeah, so one absolutely. And so what I think is really interesting is if you kind of just go to quick Google, and I actually did this morning or yesterday morning, I just kind of did a quick Google search about the news about PFAS. And really what you're kind of seeing is, within a day, a couple hours ago, well, now it'd be 24, we start to see a lot of these PFAS show up in the news, whether it's in different places around the country. There's stuff that's coming up even in Wisconsin, Michigan, the Midwest area, as well as the federal government, kind of thinking about the EPA and how they are thinking about PFAS. So PFAS is something that is really around, and it's pretty prevalent in our news cycle right now. So PFAS are per and polyfluoroalkyl substances, and you'll hear me refer to them as PFAS, and they're going to be a family of man-made chemicals. And These man-made chemicals, they will contain usually three kind of elements. They will always contain carbon, fluorine, and then potentially other elements, functional groups, etc. And the interesting part about PFAS is there are more than 5,000 different types of these chemicals. What's interesting is we really, as a scientific community, can't even agree to how many there are. Some people say there's more than 4,000. Some people even say there's more than 10,000 of these chemicals. So not only are there discrepancies in how many they are, we're really not even sure how many there could be known in the future. And these PFAS, they're in a lot of different products. They are most famously known for being in firefighting foams, or what are called AFFFs. They're also in nonstick coatings like your pans. They're in protective coatings, architectural resins, stain in water resistant products, even in paper products. I mean, the list goes on and on. They can be in dyes and inks and personal care products, medical products, even sunscreen, hair conditioners, etc. So it's a chemical or a family of chemicals that are in a lot of different things. And part of the reason it's in so many different products is it has really good ability to kind of act as a coating, a protective device. And two of the most kind of famous PFAS that we usually hear the most about are what are known as PFOA and PFAS, PFOA and PFOS. And these are the two most famous ones. Now, they are most famously known because they are relatively older in comparison to some of the new PFAS that are being created, but as well as these are the ones where we have found some negative health impacts that we'll talk about a little bit later. Now, PFOA and PFOS have actually been no longer produced here in the United States. They've been voluntarily phased out, but phasing them out, we have now started to use newer chemicals or PFAS chemicals such as Gen X or Donna that are thought to be a little less or a little more safer. Now, when we're thinking about PFAS, right, as we mentioned, there's always fluorine, carbon, and then usually there's some sort of extra elements that are involved. And when you start to think about how can we get to, 5,000 different chemicals with these, it's nice to kind of look at what these different chemicals can show. So particularly for PFOS here, it is an 8 carbon chain length, which means that there's 8 different carbons in a row here. That kind of helps us decide. And then on the end, there's usually this functional group. And in particular here, we have a carboxylic acid functional group. Now, this is PFOA, right? So when you look at PFOS, you'll see it's still an 8-chain carbon length, but now you're having a different functional group out over at the end. And when you're starting to kind of think about all of these different ones, you can have different ones like are shown here, PFDA and PFDS, right? They're different lengths long. They have different functional groups at the end. And then what's really interesting is some of the new ones is now they can have ether linkages or other linkage or put together way, but still follow those PFAS ways. As in, again, you still have fluorine, carbon, chain lengths, and then you have this connection bond in the middle. And this Gen X, like I had kind of mentioned, that is one of the newer chemicals that has been started to be produced. And again, when you start to think about it, they can have different functional groups, and those functional groups are on different chain lengths, right? And that's how we can start to get to these, 5,000 plus chemicals is you just have different lengths, different functional groups, different linkages, and this is really how you start to get so many. Now, PFAS can enter the environment in a lot of different places. We know that we can have PFAS in our groundwater. We've found PFAS in drinking water. PFAS can be in the soil, and PFAS can be even in the air. And unfortunately, for the good news is that PFAS actually is usually in pretty low concentrations in the environment, unless they are associated with specific contamination sites. But the problem with PFAS is they are extremely persistent in both the environment, but as well as the human body. And what I mean by persistent is that they can last in the environment for very long periods of time. And the reason is because they have what's known as very long half-lives. And particularly some PFAS, they can have half-lives of up to 5 years or even more potentially. And so what that kind of means is if you think about how we have, let's say we have 40 or four molecules of PFOA in the environment. 5 years from now, those 4 molecules break down into about 2 molecules. 5 more years from now, so 10 years from now, those 4 molecules are really only a single molecule now. So when you're thinking about kind of how long these PFAS can last in the environment, some of those original PFAS that were created, let's say back in the 1930s or 1940s, we are probably still seeing some of that PFAS in our environment today. So what's been out there since the 30s is still there in our, 2022 now. And what gets really complicated with some of these PFAS is not only are they breaking down or their half-life is a long period of time, they usually just break down into other PFAS. And I know I don't want to, this is a very elaborate kind of idea, but it's really just supposed to show how many different PFAS there are and how in the environment they just start to break down. And each one of these PFAS can have a long half-life. So not only are specific ones lasting for a long time, they're breaking down in the environment to getting to our famous ones of PFOA and PFOS. And what's really important now for PFAS, right? I've kind of explained there's a bunch of different ones, but not all PFAS are the same, right? So we know they are not the same because they have different chemical structures. So they can have different lengths, different functional groups, etc. But they can also have different half-lives. They can be either impurities or they can be breakdown products. But really, it's important to know that they're not all the same. They don't last in the environment all the same. So it's likely that each of these PFAS will also have different health impacts on both the environment and the humans. And so my next kind of poll question to kind of ask everybody is, do we think each one of us potentially that we may have some PFAS in our body? Like, does anybody think that they have PFAS in their body? So I got one yes, couple yeses. Everyone does, absolutely, yes, oh yes. Yes, sure, yeah. So then in simple, I would say majority of people actually do have some sort of PFAS in their, yes, there can even be some PFAS in beer. And so most people do have some PFAS in their body. Now, what is important is most people have PFAS, but they have really, really low levels of PFAS. And even some of the people that don't have or have detectable levels of PFAS, there is probably some sort of very small amount of PFAS in our body. And this is pretty well documented out there. There's studies from New York to Europe and China and Asia, all over the place, that PFAS is in a lot of us. in particular, what's I think kind of interesting is there's even a really good study that's out there that's right here in the middle about how there's PFAS in anglers or fishermen in Wisconsin. And so this is a relatively new paper that kind of has come out, but really it's important to kind of know that we are learning about PFAS being in our body for people all around the world, but as well as kind of Wisconsin we're learning more and more about it too. And so you might start to ask, well, how can we be exposed to PFAS? Where is PFAS coming into humans? And PFAS can be in your packaged food, and it can be in living organisms, so kind of what you eat, which we'll talk about a little bit later. It can come from commercial house products, stuff that we use in our daily life, whether that be from your rugs, etc. But then it can also come from places like your drinking water, which is something that we don't always think about, right? So these PFAS, they can really enter the body mainly through three big exposure routes of either consumption through food or consumption through water, or they can be through a dermal exposure via touching, etc. And so if we know kind of PFAS exists out there, we know it exists in the environment, we know it exists in our bodies, but why do we care, right? If it's there and we can't do anything about it, why should we care about it? Well, it's important to know that some of these PFAS, they can have negative health effects on both people and the environment. And before I want to preface this, I'll preface this at the beginning and at the end, that when you're thinking about PFAS and having negative health impacts, you're seeing these negative health impacts at high levels, so at high concentrations of PFAS, and for long periods of time. And by long periods of time, I'm thinking about like chronic exposure, not necessarily an acute or a short-term issue. So they can have negative health impacts, and it's usually from exposure to high levels for a longer period of time. And some of these high levels of PFAS, okay, they've been shown in people to have increased cholesterol, shown to have a reduced antibody response, as well as kind of a decreased fertility in women. And a lot of these studies, right, some of these health impacts, they come from what's seen in animal studies or toxicological animal studies, but as well as what are known as epi studies, and these are studies that kind of look at a wide range of people and how they may have elevated amounts of PFAS, and then they kind of correlate it with everything else. But PFAS, it can also potentially increase the risk of thyroid disease, osteoarthritis, ulcerative colitis, testicular cancer, and kidney cancer. So it's been correlated with these diseases. So it potentially could increase your risk. And so what's important here is we really want to be limiting our exposure to these PFAS, right? To protect human health, to protect environmental health, we really want to limit the amount of PFAS that we're exposed to. And when you think about it, you're limiting it not only so you have less amount of PFAS in your body, but also then you're not getting exposed to that chronic or continuous exposure to PFAS over long periods of time. And so you might ask, okay, we know it has some negative impacts now. We know it's everywhere. We know there's a little bit of it that could be in our food sources and our water sources. So what is being done to protect us? And one kind of big thing that I was involved with 2020, I suppose, was looking at how the Wisconsin Department of Health Services is actively creating recommended groundwater standards for PFAS. So what they're doing is they're trying to make a standard that says any less, or we shouldn't have more than a certain amount of PFAS in our water that should be, that will decrease the risk to PFAS exposure over chronic periods of time. And many of you may have heard of some of these because they're actually going through legislation right now. So our groundwater standard recommendations for cycle 10, there's going to be 2 PFAS that are involved in this. So there's 27 substances that are on these recommended standards, and 2 of them are PFAS. And if you had to guess, which 2 do you think are going through in cycle 10? Any guesses out there? Feel free to throw those guesses in the chat if you have them. PFOS, okay, we got one of them. That's a definite, that one is. And PFOA, exactly. So the two PFAS that are going through in cycle 10, which is, and it's, I should know this a little bit better, but it's, I think it's in its 3rd year of its 3-year process. And those 2 are going, should be recommended groundwater standards soon. And then in cycle 11, we did 22 substances for different PFAS, and we made recommendations for 16 different PFAS. And you may kind of question or have a question of, well, why don't we just set a recommendation for all PFAS, right? That whole family of chemicals. Well, as I kind of mentioned before, some PFAS can have different health impacts at much lower concentrations, and some PFAS can have impacts at much higher concentrations. So it's a pretty unique kind of graph here. And so of those recommended groundwater standards that are being done, you'll notice some of the recommendations are down here, in the 30 or 40 nanograms per liter, so pretty low. But then we have some that are much higher concentrations of 450 or 400,000 nanograms per liter. So you're having these recommendations, and the reason we are trying not to clump them all together per se is because there's a wide range of health impacts that can happen at different concentrations. So one way that's kind of going out there to be protective is we're making sure that we have low or no PFAS in our water sources. But as also mentioned, that PFAS can get into us via food consumption. And particularly, we may recognize that recently, the Wisconsin Department of Natural Resources have actually created fish and other animal consumption advisories, specifically for PFAS. And for fish, these fish consumption advisories are usually specific areas. So this is a graph that comes right off of the DNR website that shows in orange here, hopefully we can all see that, there are different areas where there's PFOS, which is that specific PFAS, and fish consumption guidelines that go with it. So you notice there's some for here on the Mississippi River. I believe this is for channels or locks 7, 8, and 9. There's one advisory up here in Lake Superior, and that's for rainbow smelt. And that's actually relatively new, even within the last year. We do have one in the Madison area where I'm located right now for PFAS. And then there's also, I believe this is the Eau Claire region. Now, these are specific to PFAS, right? There's other fish consumption guidelines that are out there for other contaminants, but these are the ones that are specific to PFOS. Now, the other interesting part is, as I said, they were also doing this for other animals that are potentially in contaminated areas. In particularly, there's a really well-known contaminated area in the Marinette area up here. And they have advisories out there for deer liver, meaning if you were out and you hunted a deer and you were to consume the liver, there is a certain amount of PFAS that gets correlated in deer livers that would exceed health standards. So they have set these standards not only for fish, but for other animals as well. And that's kind of what's, a couple just ideas of maybe how we're starting to limit our exposure to PFAS. But you might kind of be wondering, okay, what is the current research that's being done out there in Wisconsin? Are we continuing to look at PFAS? Are we continuing to kind of ensure that we're doing the best science that we can to kind of protect us? And that's kind of a little bit of where I have fallen into this, my position here. Where us at Wisconsin Sea Grant, our job really is here to connect different state agencies, stakeholders, and academics together in hopes to create actionable science. And what I mean by actionable science is to create science that can then be used to potentially create laws or increase our management style or decrease our risk assessment, to really have our science be ecological and have as much impact on society as we possibly can. And recently, we've even had a kind of a workshop with all of our different academic and state agencies and was in the state of Wisconsin to really focus in on specific PFAS research that they kind of hope to be done. And some of the four kind of big pathways that are four big categories of PFAS research that is hopefully being done is where you have environmental contamination. So how is that PFAS continually getting out into our environment? Different exposure pathways, right? These are going to be how is PFAS getting into animals? How is it getting into us as humans? There's some heavy work that's being done to look at how are we getting rid of waste PFAS, biosolids of PFAS, and how are we remediating PFAS contaminated sites. But then another big one here is going to be your toxicology and epidemiology studies, which are really kind of looking at how is PFAS having those negative effects? How is it having the negative effects on the human scale, worldly scale, but as well as the environment? So there's a lot of big categories that are going into this. And the hope is to as well not only have some of this work be actionable so we can kind of help decrease our exposure to PFAS. And that's going to be a lot of kind of what I have. I like to, forgive me for this picture. It's a little bit fuzzy on my screen. So I like to kind of leave this when I kind of talk to a bunch of people. I like to kind of ask if from your knowledge, kind of like, where would you like to see PFAS research? What is the most important to you as citizens and people that we all live with this day in and day out? Like what is the first kind of steps that we want to see some more research being done, and maybe where we can kind of focus some more of our effort? And so I'll kind of leave that in the air, and that will end my talk. As I said, it's a brief introduction to PFAS. We've really kind of just barely scratched the surface. So I want to thank you guys again for listening to me talk about PFAS, and I will gladly open up to questions, and we will kind of go from there.